Right, little project. Forgive this, I'm just doing it on my iPhone. So what I've got is a lathe, Boxford lathe with a D1-3 spindle on it. I want a smaller chuck on it for some stuff, because the one that I've got on it is 125mm. I've got a 4-jaw which is 160, but for some of the smaller stuff you manufacture, if you're doing sort of, let's say, you know, making model steam engines like that, for example, there's some quite small stuff on it, and the material gets swamped, for want of a better word, in the chuck. So I wanted a smaller chuck. Excuse me. So what you have to do is, obviously with the bin and spindle, for those that don't know, which most people will, it has to be mounted on a back plate, such as that. Now the smallest D1-3 back plate that's made is 100mm, and this is an 80mm chuck from Pratt Bernard. Now, so what I'm going to do is, this just covers those holes there. So, and on the back of these cam lock mount goes these here, which have to be positioned at the right depth, otherwise they won't lock into position and the chuck will end up wobbling, which isn't good. These actually got a little mark on them, which probably are there to assist in the depth that each one's in, so that they've got to be the right depth in the hole, and they don't screw right down. So first job will be to check those there, get them into the right depth on all three on the lathe. I've already mounted this faced up to the lathe spindle, the tapered spindle on the lathe, and there's to make sure it is a snug fit actually on the spindle, i.e. it's not just relying on the cams to keep it into position. I have actually had to buy a very cheap D1-3 back plate, which does rely on that, on the cams. It doesn't snug up nicely onto the taper. I don't know whether you can see, but there is a taper inside that which matches the nose spindle of the lathe. This one was made by Comtas. It's what's called a part machined. So it's the back and the spindle is mounted. Then you have to do the front for the lathe, for whichever chuck you want to do. So what I'm going to do is I will first of all mount this in the lathe. There's a few rough edges here because it says it's an unfinished one. I can feel some rises there. So I'll skim a face of that. I'll then need to machine in a register to match very tightly and snugly onto this register. That's it, machined into the back of the chuck. I've not measured it yet. I suppose I could actually look it up on the documentation of the that came with the chuck as to what it actually is. But it's got to be snug, otherwise you'll get run out, and it defeats the whole object of having buying a decent quality chuck. Right, I've got the cam locks in. There. I need to put some Allen bolts in there which stop it rotating. These actually quite float, not float as such, but they actually are, and it's those that keep them from rotating out, because I think if they rotated while they were inside the nose, it would actually they could probably get jammed and get stuck onto the spindle. That wouldn't be desirable now, would it? So I'll put these in and check it up, and next you'll see it is when it's on the lathe, hopefully spinning reasonably true. You'll probably know this anyway, but if you don't, but particularly with the first machining, when you're first doing it, the tapers and the gap between here, basically all surfaces that mount to the spindle and all the surfaces of the on both sides of the spindle and the chuck have got to be spotless, because if there's any grit or any swarf or anything in there, it would throw this out of line. Even a small amount would make a large difference, and it would be there forever and a day unless you re-skimmed everything, which we don't want to do that. So that's it. It's important, obviously, when you put each time you change your chuck, but even more so when you do the first machining. Okay, I'm taking a facing cut, just to about 2.5 pound there. Pretty nice and slow, cast iron. So it looks as if it's taking an even amount off all the way around. So the face must be running reasonably true, if not spot on already. Okay, I faced that off. It cut evenly all the way across, so it must have been running reasonably true, apart from the slight burrs of these hairs which were raised, but the actual thing was running pretty spot on. I'm now going to reduce the size of it to 100mm, the diameter of it to 100mm. I've just touched off. I've zeroed my y-axis, so I have measured it. It is 125mm spot on across. So it's not mega hyper, it's not critical, it's just predictable. It's got to be right, there's no point in doing it. So if I carve off 12.5mm either way, it should drop off the 25mm that's required to take it down to 100mm. Okay, lesson for the day. I decided to change the bit that was in the diamond tool holder to a crow bolt bit. Not cobalt, but crow bolt. What the difference is, I don't know, perhaps somebody could tell me. And then discovered that not only was the bit not on centre, the existing HSS bit was not on centre, it actually also wasn't particularly tight either. I remember sharpening the bits last night and just slotting it in. So there's a lesson. Never leave anything half done. I'd have been better off leaving the bit out of it totally, because today when I came back to it, I'd forgotten all about that I hadn't tightened it up or checked the centre height of the bit. So I'm getting a better finish, which is what I always wanted. But it's a double-edged sword. It might be the crow bolt, or more likely it's to do with me being stupid. Okay, I'll give it a quick interlude and tell you that there. Cheers. Well, there we are. The diameter's down to 100mm. I could probably take it a little bit further, but I think what I'll do now, I'll cut the register for the chuck and see afterwards. Yeah, I probably could take it down a little bit further just to sort of might look prettier, like me. Right, okay, see you in a bit. Right, what I've got here is the register started to form. It's about 3mm proud, which is the recess depth in the back of the chuck. It wants to go a little bit smaller yet, but I've just basically roughed it out. So it's nearly to size before I do the final fitting. I'm going to have a cup of tea and let it cool down. So I'm going to get it as snug as possible to stay that way. You'll notice that the spigots that go in the back, they're protruding through the register. It's a price I have to pay for putting such a small chuck on a D1-3 fitting, but it's an 80mm chuck. There's going to be very little load put on it, very small light cuts. So I don't envisage a problem at all. It seems to be nice quality cast iron. I'm sure it'll be fine. And then when I've got it down to size, I'll show you when I've got it to size and it's fitted, and I'll put some put the PCD holes there. So it's getting there, getting close. So I'll have a cup of tea, let it cool down. Cheers. Right, okay, I have taken that down a little bit further. Just left a couple of millimetres there. Just put a little, I'll put a tiny little chamfer on that there. I've not chamfered here. I've just run a bit of cloth along the face of that while it was turning. I don't want to chamfer that yet, and the reason being is when I put it in the mill for the DRO to do the PCDs, I want to pick up off there for the centre with a laser edge finder, and if it's chamfered, it'll make it trickier. I suppose I could do off that one, but that's chamfered as well. Very good, those laser edge finders, but they don't like chamfered edges. It's effectively. So I will put a chamfer on that, so just so it looks a bit nicer. But I ain't going to do it just yet until I've got the PCD holes sorted. I'll probably give that cast iron a bit of a polish with some memory cloth or something. So anyway, definitely bedtime now before I make a mistake. I'm tired. Okay, so we're out of the lathe and onto the mill for the drilling of the PCD holes. I should also mention, perhaps, I don't know whether you can see it, there's a slight mark there, witness mark. I've put that there as it lines up with a mark on the lathe spindle, so it always goes back the way it came off. Don't know how important that is, because it really was a very, very good fit onto that spindle. When I took it off, there was no dust from the cast iron of this into that taper there, or on the back plate itself, the back of the back plate, which tells me that the people that made this knew what they were doing and did a good accurate job. So any inaccuracies will be down to me. In here I've got a laser edge finder that I'm going to find the centre. Used to find the centre of the back plate. I'm going to use a DRO. I don't know how successful it's going to be. Me trying to do this one-handed, so I might have to give this bit up as a bad job. But we'll have a go anyway. As I say, it's on an iPhone, and so I'm just sort of hand holding it one-handed. I'll probably do a few of these, because I am quite a newcomer. These little videos. I think it's important that perhaps mistakes be witnessed, because people learn as much off mistakes as they do off things going right. I know I do. And I have made mistakes. I was very lucky with the loose tool bit, that I hadn't done my prep work properly, and if that had been done later in the day, I was getting closer to me where I needed to machine it to, it would have been a bit of a disaster, and it would have been an expensive piece of cast iron to write off, because it's they're not cheap, these the quality part machined back plates. So okay, this is what I'm going to do. I'm going to switch on the laser edge finder. Now I don't know if this is going to show up on camera. I've got some lights down. It's gone a bit wobbly. It's because I'm going to find the edge. Right. I don't know whether you can see the dot going on. I'll probably make that. It's running a little bit big at the moment. You can vary the size of the dot. Right. Now what we've got there, when I didn't chamfer the edge of this here, you remember on the you can, I think looking through the, maybe you can see just on the edge down on the bed of the mill, and with not chamfering that, I don't know whether it's showing, but I can see a slight mark there, and then half of them, which she's splitting that laser beam in half. Half's on the bed, so that's that. So x-axis, I'm going to 0 it and go over the way. It's kind of wobbly as heck because I'm whining like a badger. This is nowhere near the centre of this, so I might go back and do this again, give me a better shot around here. And around here, I don't know whether you can see it. I can see it anyway. Sometimes it's there. I'm splitting the beam there. I can see it on the bed of the mill. Just okay. So it's there. I'm going to be x-axis there. I'm going to select X and half it. Now if I take that back to 0, I probably won't be able to hit the mark spot on with just doing it one-handed. I'll see if I can. I'll have to put it down and pick it back up again. It's difficult one-handed. There we go, managed it on that one. I'm going to do the same with the y-axis. So swap hands. Look round. I'm looking for it just striking half on. I can see it, but looking at the viewfinder, the iPhone can't. This is why I didn't put a chamfer on, so it will make it easier. Zero the y-axis. The edge, excuse my wobbling about, and then trying to get in gently, and I can just see it on there. Put some shadow on it there. There, you can see it splitting the beam. I think I can see on the screen there both. Right, okay, so select Y and half that. And if I take that back to 0, it'll be right that way. Apologies for the jiggling about. But as I should have perhaps set it up on a tripod really. I'm going to set that to 0. Now what I'm going to do, oops, gone past it. I'm probably going to just tap that in. Right. The x-axis I'm going to do again because I was quite far off centre with that. So I'm going to do that again, but off camera. So just give me a little bit more accuracy. But it'll probably be fine. But we'll find out anyway. It's always best to do it as near to the centre as you possibly can. Okay, I'll be back in a second once I've done that. Again, interestingly, in this 12-page little literature that came with the chuck, nowhere inside it does it tell you what the depth of this the recesses in the chuck, or the diameter of the you have to machine to how to measure that. Nor does it tell me what PCD the holes are in 12 pages. It tells me how to fight fires and all things like that, but nothing to do with what might be important. So I had to look at it on the net, and I hope it's accurate what I've looked up. It's according to the net, the PCD of the holes is 71.3. So I quite like this DRO because it gives like a graphical display of what you're actually doing. So if you're going to do something daft, you can see you've programmed it wrong. So press this here, come into the PCD setting. I'm on the centre. I've already got that programmed in. So there's asking the centre, and that's fine. Got that. Diameter 71.3. 71.3. Enter. Next. Number of holes 3. Enter. Start angle 0. 0.000. Enter. End angle 360. Enter. Right. What I also like about this is, I don't know about other displays, this is the only one I've got experiences of. It lets you cycle through a few times. So what it is to get the whole of the first hole, I have to dial at 35.645 to read 0. That will be my first hole position. I can then cycle through, and it's showing me where the holes, so I can see. Right, you're in the ballpark, I think you've got this right. And it's giving me the coordinates, and each time. But then I can go around again, which means, first of all, I don't have to keep changing bits while it's in one position. I can go around with my centre drill. I can then go around with the tapping drill size, which for this, I think these are 5mm, I will check. I think the tapping size for that is 4.2, I think. And then I can go around with a tapping, I'm not sure what the name of the device is, it just holds the tap square as you go down. So I can actually go around. I don't know about the other ones, but this is so in that case. So I'm going to do this to start with, and I'm going to zero that. I'm not going to go all the way through, right? And I'm going to drill centre hole. When I get that zeroed, I'm trying to do it one-handed. Have I gone past it? I have. It's difficult doing it one-handed when you get in close. There we are. But they're both at 0, so that will drill me that hole there. Yep. I'm not going to show you the whole process. I'll show you the next one after I've drilled this. There's no point in watching boring drilling, is there? Okay, there we have it. Everything went nice together nicely on the fitted fine. DRO did its job it's supposed to do. This here, you can't have a printer actually. But the reason I put that in there, I happen to know it is actually very, very straight. I've just had it spinning. It runs very sweet. I've not put a clock on it, but I will do. But it's surprising actually, even if something's a couple of thou out, you can normally see it. Amazing really, once it's rotating. But I will put a clock on it. I've not put one on yet, but I'll just spin it over. And, I don't think it's doing funny things on the camera at all, but I can see that's running straight out here as well. There's not a lot there. It's pretty on the money. I say I will put a clock on it and measure it, but I happen to know that's quite a straight piece that someone's using this. So anyway, that's that. I'm going to chamfer off here. And I'll put some memory cloth on this as well, so it's nice and shiny. So that's the job. So that's it, finito. I've put a chamfer on it as I said I was going to do. I'll have to run a little test on it. Taking it down to small as it weaken the back plate. Yeah, probably, but not a lot. I wouldn't have thought it's going to matter for what I'm going to cut on an 80mm chuck. If I were to crash the lathe and it was enough to break the back plate, it'd probably write the chuck off anyway. So, you know, for any future accurate work. So, it's certainly handy. I can get small things in without it being totally swamped. A 4-jaw chuck, that probably is different because by its very nature, a 4-jaw is going to do a lot of interrupted cuts, isn't it? Square bar, which should give a lot more vibration. Probably be strong enough, but it's I don't know. But I wouldn't like to take it any smaller than that. What have I learned? I've learned to double check everything, like tool tightness and etc, etc, etc. That was the most valuable one. That was nearly a disaster, as I mentioned a couple of times. As I say, I'm a newcomer to it, but hopefully this will help other newcomers to tackle something that. Don't be afraid. It's worst thing that can happen is you end up eating the chuck and a new set of teeth. Worse things can happen. So anyway, I'll just spin it over and I'll show you the run out on it. Which so there we go. Oh, that's going a little bit quick. Hold on. Just slow things down. That's it. Now then, I don't know if that's snapping into focus or not. Come on, get in. Well, I can tell you, it's about a foul run out, which for a 3-jaw chuck, I'm more than happy with. In fact, I'm very happy with for a 3-jaw chuck. the video scroll trick that is. So I don't think it'll focus on it. No, it's too close for it. So all in all, I think it's a successful exercise. I don't know how many bits I have to drop out of this video that I've made because I'm just on the iPhone. It's a bit shaky and wobbly at times. Just me having a holding it and doing it one-handed. Anyway, I hope it helps people. It's helped me doing it. So sometimes I think it's important to learn by mistakes. I think sometimes you can learn as much from mistakes that you've made as when they've gone right, as long as you take notice and learn by them. Okay folks, see you again.